Hi everyone. Oh, this is wireless. This is great. I'm Toma, and today we'll talk about contained intelligence, secure sandboxing for Gen AI code. I'm a software engineer at Daytona. I've been in Daytona since the start 2 years ago, but I've been working with the team for the past, I think, 7 years.
Sorry to interrupt. Can you put the microphone down, please? It might damage it. Thank you. It's easy enough to hear if you step back from it. Thank you.
Okay. Is this okay? Can you hear me? Yeah. Okay. Should be good. So let's dive right in. So what even is Gen AI code? I think everyone here has generated some AI code in the past. It's basically just code generated by an AI agent of any kind. But what even is an AI agent? So the most basic form of an AI agent, it's essentially an application that talks to an LLM and serve some user. And this is the, let's say, most basic AI agent that you can find. This is what ChatGPT was when it was first released, Claude when it was first released. Essentially just an application talking to an LLM in some kind of loop. And these sort of AI agents are very skilled at handling prompts such as this. By the way, shout out to the Shift conference because I made a talk for them last week. But let's open up Claude. Yep. And let's generate some haiku poem about Shift, but let's generate it about some Daytona meetup. And this is no problem for Claude or for any other AI agent that's talking to an LLM. Why? Because it's a large language model. It's meant to take an input of a string and generate some output in return. This is probably not a haiku judging by the form, but you get the gist of it. And then what if you give it a prompt, generate a Python function that takes 4 numbers and multiplies them? Again, Claude is very trained, very skilled at generating Python code. This shouldn't be an issue, and it's very easy to validate. This is why I chose it. Again, multiply 4 numbers, return the output of the 4 arguments, nothing special there. But what happens when you ask Claude what's the square root of these 2 huge numbers? So let's test it out, and it will go like you expect it to go. Claude will try to deduce the answer of this call by basically moving it through steps through essentially language, and it's essentially writing it on paper and trying to deduce the number. If we check out the number, the square root is 7,046,000 something. But if we take the square root of these 2 numbers and actually like calculate it, and I use Chrome as my go-to calc, so SQRT over this, you'll get 7,046,452, which is actually a lot off from Claude's answer. And why is that? Why is that a problem for Claude? Well, and for any AI agent? Well, it's a problem because these AI agents don't have access to tools. They just have access to LLMs, and LLMs are trained on just natural language. They are made to be conversational, talk about any topics, generate haiku poems and anything like that. But they can't use external tools. In this case, they can't use a calculator. So what does tooling enable these AI agents other than just solving math tasks? So they enable determinism, and that's one of the most important parts that these tools bring to the table. With LLMs, you know that when you give a single prompt, it can generate thousands of different results. No one here probably saw the same answer to the same question before, but with calculators, it's 2 + 2 is always 4, 5 × 5 is 25, and with these external tools, the determinism is something that's very important to these AI agents. Then it's speed. It's much faster for us as humans. It's much faster to calculate these equations on a calculator than to just write it out on paper. And it's the same for AI agents as well. If you give them access to these tools, they will be much faster in computing the answer. And lastly, the context window. We all know how these agents can hallucinate very quickly if the prompt grows too big or the memory of that chat grows too big. If you offload some of those calculations and some of those calls to these external tools, you will save up on that valuable context window as well. So if we think about this prompt as engineers and we say to these AI agents, okay, but just write me some Python code and execute it to determine the result. And this is kind of how we as engineers tend to solve these kind of tasks through code, right? So if we give Claude the prompt, which is, which is this one, and I just appended if you fail, don't try again, because Claude can just go out and like try 10 times. I just want to save time. It will write out some Python code and it will try to analyze it. And the Python code is essentially like 2 lines of code, right? But as you can see already, Claude made a mistake. He tried to execute some JavaScript, but Claude actually can't execute JavaScript, and it tried again. It can't execute the JavaScript. It has a built-in interpreter that will try to analyze the code by statically like seeing what's the code and trying to figure out the result. But again, that's just the LLM talking, no external tool calls. So what can we bring to the table to enable Claude and these AI agents? The necessary tools and connections to talk to these tools, right? So what are the tools that AI coding agents specifically need to be able to complete these tasks successfully? So if we think about this prompt, I sort of like think of it as 2 prompts in one. One is what's the square root, and write some Python code, and all you need for that is the LLM. We saw before, LLMs very good at handling inputs that are strings and outputs that are strings, such as code examples or actually writing code. And then the last is executed to determine the result. And this is the missing piece. This is the tooling needed for these AI agents to actually execute and run the code. And this is where the sandboxing comes into play. So this is all let's say, all the tooling these AI coding agents need to improve their efficiency by a lot. And these sandboxes, you can think of them as secure execution environments. So if you actually go back, I think I mentioned this before, when Claude makes tries to calculate a math equation, it's essentially writing it on paper and trying to figure it out. The same thing is with code. So these AI agents just talking to an LLM, it's like all of us like doing math exams in university. You just write it on paper. You don't have access to an IDE, no LSP, no terminal to validate it, no compile tools. And I don't know about you, but I wouldn't like ship anything to prod that was written on paper, right? You didn't validate it, you didn't compile it, you didn't run unit tests or whatever. And this is the missing piece to these AI agents as well. For them to be, let's say, completely quote unquote correct, they need to be able to compile the code, run, I don't know, LSPs to validate the syntax, to lint the code and whatnot. So the missing piece, the sandbox environment, enables these AI agents to get the file or code snippets into a sandbox that is a full environment, and then get the result. The result can be, I don't know, compilation result, terminal output, or I don't know, if the code generates some files, it will get the files into the agent. And that result is more context to the LLM. It can be, okay, this compilation failed, and then the LLM can figure out, okay, I need to fix this in the code to make sure it works next time, and things like that. So how does the agent talk to the tools? This was mentioned before. You can code it yourself using APIs and SDKs. Like before, your question, I think, was, okay, why wouldn't anyone just use any API, such as GitHub's API, Slack's API, and integrate it themselves into your AI agent? But I think MCP is not like the full solution, but I think it's the way to go with this kind of setup. And this is a brief MCP architecture diagram. It's, as I said before, 2 parts. One is the MCP server and one is the MCP client. The client is the agent. It's Claude, your IDE, any AI agentic tools that support the MCP protocol. And then the server is whatever, the server is essentially the application that talks to tools. It's GitHub's MCP server that talks to GitHub. It can be a server that just serves some data. For example, you can have a server that just serves your emails, that just serves your, I don't know, local files into this AI agent. And lastly, in between these 2 components is the protocol itself. It's JSON-based, open source. You can find it on GitHub, on Anthropic's GitHub, and MCP.so, not like the full registry of registries. MCP.so has, I think, 12,000 MCP servers currently, and you can find a lot of them that are very useful and easy to just integrate into your agents. So let's go back to the prompt and let's try to give Claude the necessary tools to actually run this Python code and get the correct output of this equation. So let's go back to Claude. Actually, let's go back to the terminal first, and let's increase the font size. Settings, appearance. Let's do 40, should be fine. Yeah. Okay. So the first step to do is to install the Daytona CLI, and that's brew install Daytona IO CLI Daytona. I'm just gonna skip this to save time. And then what you do when you get the Daytona CLI is Daytona login. Daytona login will give you the selection to log in with browser or set an API key. I'll skip this as well, not to leak my API keys. But I generally just tend to use the API key for this. And then do Daytona MCP init Claude. This is all you need. Once this command is run, the Claude will have access to Daytona's MCP and be able to spin up these remote sandboxes and execute code inside of them. So if we check out the tools right here in Claude, you'll see that the Daytona MCP is enabled, and you'll see all the tools that Claude has with the Daytona MCP. It's create a sandbox, create folder inside a sandbox, download files, execute commands, upload files, etc. Essentially all the tooling an AI agent would need to execute code it generates and, I don't know, run any kind of command against this code. So if we take the same prompt and say execute the code in Daytona, let's see what Claude cooks up. So as you can see, because Claude is aware that it has access to the Daytona MCP, it knows it can create a sandbox and it can execute Python code inside. So this first call right here was to create a sandbox. It gets the ID of the sandbox, and then it knows it can upload the file to the Daytona sandbox, and then it generates the code, which is, again, like before, the two lines of code, and then executes the command automatically that will run this code. Now it's Python, so it just runs it with Python 3, and it gets the output. And as you can see, this is the result I was talking about before. This is the result of the execution, and Claude knows how to interpret this result. And as you can see here, it interprets the result as needed, right? It gets the STD out, and it knows that this output right here was the needed execution result. Again, this is a very, very basic example, but this can be applied to any kind of code generation or entire application generation as well. And this, why, again, maybe moving to your question before, why is MCP the right way to do this? MCP allows you to then take Daytona's MCP and integrate it into any kind of AI agent. This is not Claude specific. No, not anything in this code of Daytona's MCP is like Claude specific. It's just the MCP server and Claude talking to it using the protocol itself. So what are some of the other use cases for these kind of remote sandboxes? You can run data analysis workflows with this as well. For example, you can like dump a CSV file in one sandbox. You can create 1,000 replicas of that sandbox and then generate Python code to analyze this data on different, different workflows. Or some highly parallel isolated workflows. I don't know, you need to run 10,000 different iterations of the same code to maybe test it out and see which version works the best. But I think one of the coolest examples that was brought up recently was reinforcement learning through these sandboxes. So training a code-gen model using these sandboxes side by side, where once you generate the code in the training process, you give the training pipeline access to a sandbox to actually compile the code and execute it, and then that's the reward structure for the training process. And this there's a paper out there on Hugging Face, I think, and this improved the code generation quality a lot because, as you can understand, when you get the chance to compile the code and test it, the model that was trained on that better quality code was a better model in the end, right? And so secure sandboxes, as I said, endpoint for everything, any kind of actions you want to use, that's all available through these Daytona sandboxes. I forgot to mention we have a Python and TypeScript SDK where you can use our APIs to manipulate sandboxes as well. fully Docker compatible. Any Docker image works with these sandboxes. Self-service or on-prem works with any language. Again, Docker compatible. Human interactable, which means that you can even enter the terminal with these sandboxes. I won't show that just to save time. So in our dashboard, you can just click a button, enter a terminal in the sandbox, and then you can check out what's going on inside. And as Marian mentioned at the beginning, fully open source. You can check out all the code. And you can start all free with $200 of credits right now on app Daytona.io. And give us a try. Follow us on GitHub, Twitter, and that's it. Thanks for listening.